Heat treatment essential tips and tricks. Choosing the right materials. Optimizing design for efficiency. Perfecting the heat treatment process. Choosing the right materials. Selecting the right materials for heat treatment is critical to achieving desired properties like hardness, toughness, and corrosion resistance. Material compatibility with specific heat treatment processes ensures optimal performance and longevity. Consider factors like cost, mechanical properties, and intended application when choosing materials. Optimizing design for efficiency. Efficient design considers both material properties and heat treatment methods to meet functional and cost goals. Simulation and testing during the design phase help identify areas for improvement and reduce waste. A well-optimized design balances performance and manufacturability for the best outcomes. Perfecting the heat treatment process. Perfecting heat treatment involves precise control of heating, soaking, and cooling phases to achieve specific mechanical properties. Each process, such as annealing, quenching, or tempering, must be tailored to the material's characteristics. Regular monitoring and adjustments ensure consistent quality and performance. Large critical plastic mold. Critical aerospace components. Failed heat treatment. Failed heat treatment occurs when improper techniques or conditions lead to defects such as cracking, distortion, or undesired mechanical properties. Common causes include incorrect temperatures, uneven heating, or improper cooling rates. These failures can compromise material strength and performance, often requiring reprocessing or scrapping. Proper prevention. Proper prevention in heat treatment ensures safety and quality by adhering to safety guidelines, such as wearing protective gear, maintaining equipment, and following the prescribed process. This includes proper storage and handling of materials, regular inspections of furnaces, and monitoring process parameters to avoid defects like distortion or cracking. Remove all sharp corners completely by grinder or machining. The groove shape should be in U configuration. Avoid shapes with sharp corners such as V shapes. Used to prevent cracking during heat treatment. Must prevent the narrow holes for shrinkage during heat treatment. Must prevent the front and back. Used to protect the critical component during heat treatment. Proper loading carboizing components. Proper thermocouple placement is essential for accurate temperature measurements. Ensure sufficient immersion of the thermocouple in the process, with a recommended depth of at least 10 times the protection tube's diameter. For surface measurements, place it in a location where it reflects the true temperature, avoiding hot or cold spots. Correct insulation of the thermocouple from direct heat radiation from the furnace heaters. In heating and cooling systems, heat flows from higher to lower temperatures, with heating agents like steam adding heat, while cooling agents such as water absorb it. The flow direction in heat exchangers is chosen based on efficiency and material considerations. Different designs, such as counterflow or parallel flow, enhance heat transfer to optimize system performance. What is NADCA? The North American Die Casting Association, NADCA, is a trade organization dedicated to advancing the die casting industry in North America. NADCA provides resources, training, and certifications to support manufacturers and die casters in solving technical, operational, and business challenges. Toughness. Faster quench rates result in increased toughness. The cooling rate is a function of the size of the tool and the quenching power of the equipment used. This relationship should be established before the heat treatment begins. Causes of distortion. The surface cools faster than the core. Above the Martensite transformation temp. The surface and corners contract faster than the core, causing stresses which lead to distortion and crack the tool. The greater the temperature difference between the surface and the core, the greater the risk. Isothermal treatments. An interrupted quenching is recommended when the difference between the surface, Ts, and core thermocouple, Tc, exceeds 90 degrees Celsius. Once below 540 degrees Celsius perlite will not be produced. The tool may be held at a constant temperature between 400 to 450 degrees Celsius for 30-minute max to allow the surface and core to equalize before quenching further. Although the surface still cools faster, the temperature difference is reduced, so the stress is reduced. Stay tuned to this YouTube channel for more updates and insights.